What's the difference between a sprinkler that's working and one that's working correctly? Most of the time, it comes down to small adjustments or a bit of cleaning, simple actions that can make the system perform like it did when it was first installed. I'm Dr. DeBusk, and in this section, we're going to look at what it means to clean and adjust sprinklers as part of routine irrigation maintenance. We'll talk about how to identify when a sprinkler just needs an adjustment versus when it crosses a line into a repair. And we'll look at common fixes like adjusting arcs, radii, and trajectory, cleaning clogged nozzles or screens, and correcting alignment issues. By the end, you'll see how these basic maintenance steps keep irrigation systems efficient, extend component life, and prevent costly service calls down the line. After reviewing an irrigation system, it's common to find components that work but aren't performing exactly as they should. Maybe a sprinkler's tilted or a nozzle is clogged. These small issues can be corrected by cleaning or making minor adjustments, bringing the system back to how it performed when it was first installed. Most companies include cleaning and basic adjustments in their regular maintenance plans, so these are handled during the same visit when the issue is identified. However, each company needs to clearly define what counts as an adjustment versus a repair. In this training, we'll use a simple rule of thumb. If the service takes longer than the typical system review, or requires tools or skills the technician doesn't have, it's a repair. Here's an example. Raising a sprinkler usually means digging and cleanup, which makes it a repair. Straightening a sprinkler, on the other hand, can usually be done in minutes with minimal effort, so we consider that an adjustment. Every company should train their technicians on where that line falls, because it impacts scheduling, pricing, and customer satisfaction. When we perform a system review, or what we call a wet check, some sprinklers will need a little attention. These are issues that keep the system from performing the way it was designed to. The most common ones include sprinklers that are aimed incorrectly, have arcs or radii that are out of alignment, or have clogged or damaged nozzles. You might find sprinklers that are leaning, not popping up all the way, or shooting at the wrong angle. And one of the most frequent problems, especially in older and thick turf areas, is when grass has grown over the sprinkler head. All of these issues can usually be corrected with a quick adjustment or cleaning, which is why documenting them during your inspection is so important. The irrigation system review checklist is designed to capture exactly these kind of details: what was found, what was fixed, and what still needs to be done. The remaining presentation will break down how to do each of these. When do we adjust the arc? Two common triggers: when water is going off target on either side of the arc, and when the throw is reaching beyond where it should, like into shrub beds or onto the driveway. Before you touch the arc, make sure the nozzle itself is the right one for the site's pressure and head spacing. The wrong nozzle means you're tuning an instrument that's out of key to begin with. For fixed arc spray nozzles, the arc isn't adjustable. If you need a different arc or radius, you swap the nozzle. As a pro tip, when you have the water on and you've identified what nozzles need adjustment, clamp a pop-up sprinkler repair tool at the base to not only identify which pop-up needs attention, but keep it up. This tool will also allow you to pull up the pop-up if needed. With the water off, remove the nozzle and screen, clean or replace the screen, then install the new nozzle with the screen. Give the nozzle a slight snug with pliers, just past finger tight. Aim by rotating the riser, turn on the water, and fine-tune. Variable arc nozzles, or VANs, give you flexibility that fixed nozzles don't. Most can adjust from 0 up to a full 360 degrees, though a few brands stop at around 330. You'll find arrows and a left edge indicator on the top. These show which way to open or close the arc. As you widen the arc, the nozzle orifice opens and flow increases. As you close it, flow decreases. Just keep in mind, not all VANs are matched precipitation rate nozzles, so mixing different brands or models can throw off uniformity. To adjust one, snug the nozzle slightly more than finger tight. Locate the left edge indicator, then use the arrows to guide you. Depending on the brand, you either rotate the middle band, like Rainbird, or the top cap on models like Hunter, Toro, and K-Rain. Because VANs are adjustable, they're also easy to knock out of alignment. Mowers, foot traffic, or even curious hands can shift the arc, so check them more frequently than fixed nozzles to make sure you're not wasting water or missing coverage. Rotating nozzles are adjustable within each brand's limits. Some cover wide ranges like 45 to 250 degrees. Others use several part circle models to span the range. You'll also see dedicated full circle and strip options. Pay attention to the brand's fixed side indicator, a groove, an R for right stop, a flat spot, or a white strip, so you set the arc from the correct anchor point. First, slightly snug the nozzle so it won't wander. Turn the water on. Rotate the riser to put the fixed side on your target edge. Remember, Toro uses a right stop, Hunter, K-Rain, and Rainbird use a left stop. Then open or close the arc. Some models adjust by pushing down and turning the cap, others by rotating a middle band, and some offer a small tool. If the arc is right but the aim keeps drifting, tighten the nozzle on the riser just past finger tight. Rotors come as full circle only or a combined full part circle model. Most part circle rotors adjust from about 40 degrees up to full circle and will ship from the factory with an arc set around 180 degrees. Some full circle rotors reverse at 360, others are true full circle. And just like rotating nozzles, rotors have a fixed stop side that varies by brand. Know your hardware before you start. For a tool-based adjustment, aim the fixed side first. For the tool, you can use a flathead screwdriver or there are a variety of special tools. Insert the tool into the arc slot, turn toward plus to increase, minus to reduce. If there's an arc indicator, use it to set the degree you want. It may be easier to adjust a rotor with the water on. I like to help the rotor halfway by hand and then let it finish and reverse. Do that in both directions to confirm the arc is correct. In the real world, wind happens. If you set arcs on a calm day, give yourself a touch of overthrow at the edges so when the wind picks up, you don't end up with dry strips along sidewalks and bed edges. Some rotors adjust by hand. With the fixed side aimed and water on, hold the ribbed ring, if there is one, and rotate the turret to line up the indicator arrow with the arc you want. Some models align using the stream. When that's the case, follow the brand's instructions. Again, hand assist partway and let it complete the turn to check both ends of travel. When we talk about adjusting the radius of a spray or variable arc nozzle, it's all about controlling how far the sprinkler throws water. Most models adjust with a small screw right in the center of the nozzle, but that adjustment only works properly if the screen underneath the nozzle is in place. The range is limited, usually about a 20 to 25% reduction. If you try to reduce it more than that, it'll look fine while the system's running, but once it shuts off, the screen shifts slightly. When you turn the water back on, that nozzle may barely run or shut off completely. If you need a significant radius reduction, it's usually better to just switch to the next smaller nozzle size. And here's a key tip. When changing to longer radius nozzles, always confirm that the new total flow doesn't exceed the zone's capacity or the source pressure. Rotating nozzles can also have their radius shortened when they're throwing too far. Just like sprays, the radius of adjustment is limited to about 25% of the maximum radius. Depending on the model, you'll either turn a small screw at the top, just like a spray nozzle, or rotate a radius adjustment ring or band by hand. Some manufacturers also offer small tools that make this easier than trying to fit a tiny screwdriver. After adjustment, always confirm you're still getting near head-to-head coverage. That's what keeps your precipitation rate uniform and your efficiency high. In rotors, radius adjustment works a lot like sprays, but here the adjustment screw doubles as the piece that holds the nozzle in place. When you turn it into the stream, it breaks up the flow and shortens the throw. Again, the practical limit is about 25%. Push it farther and you'll start distorting the stream, causing uneven coverage. If you really crank that screw in, it can actually drop through the nozzle housing. When that happens, the water pressure blows the nozzle right out of the rotor and the screw's gone. To adjust, turn the water on, insert your hex wrench or flat screwdriver through the membrane over the nozzle direction arrow and fit it into the screw head inside. Turn clockwise to reduce the throw, counterclockwise to lengthen it. Then check the stream across the whole arc to make sure it's even. Even if the arc pattern and nozzle type are perfect, sprinklers can still water the wrong areas if they're aimed incorrectly. This usually happens when the sprinkler body has shifted slightly, maybe from vibration, mowing equipment, or soil settling. Aiming a sprinkler realigns the fixed side or stops so that the water goes exactly where it should, across turf and planting areas, not onto fences, driveways, or buildings. We've already talked about how to set fixed stops when adjusting arcs. Now we'll look at how to re-aim both spray-type sprinklers and rotors so that the system performs as designed. For spray sprinklers, aiming is done by rotating the riser tube inside the spray body. That ratchet mechanism you feel is there to keep the riser from spinning freely, but it still allows adjustment. When you're re-aiming a spray with a van or a rotating nozzle, turn the riser first to put the fixed side where you want it. Then you can fine-tune the variable side of the arc afterward. Turn the water on so you can see where it's spraying. Use your hand or to rotate the riser. If the ratchet's tight, you can use pliers, but do it gently so you don't damage the tube or the seal. After that, check the arc edge to make sure the spray ends right where it should. When a rotor is spraying off target, it's often because the sprinkler body itself turned on the swing joint threads. That loose connection not only throws off the aim, it also leaks, keeps the soil too wet, and eventually causes the sprinkler to sink. To correct it, start by exposing the sprinkler and unscrewing the cap. You may require a channel-type pliers to hold the rotor and another to loosen the cap. The one in the photo is from KeyFit Tools. Pull out the internal simile and check the tightness of the swing joint threads. Tighten them if they're loose, but don't over-tighten. The threads don't need sealant. Then, with the internal in your hand, rotate the turret to its fixed stop, right or left, depending on the brand. Align the nozzle direction arrow to the fixed edge of the area you want covered. Insert the internal back into the case, lining up the notches and ribs, then screw the cap back on hand tight. Finally, turn the water on and confirm that the fixed side is aimed correctly. If it's still off, don't try to twist the rotor case again. Turn off the water and start from step 2. That prevents damaging the threads and keeps your alignment solid. Any sprinkler can become tilted over time, maybe from mowing, foot traffic, or soil movement. When that happens, it completely changes the spray pattern. You'll see water shooting high on one side and low on the other, and that means uneven coverage and wasted water. The amount of work it takes to straighten a sprinkler depends on a few things: how far it's tilted, whether it's attached to a flexible swing joint or a rigid pipe, and what the soil is like around it. If the sprinkler's on a flexible connection with loose soil, you can often fix it in a minute or two. But if it's surrounded by rocks, roots, or compacted clay, that same job can take much longer. To straighten a sprinkler, start by digging a small notch on the side it needs to lean toward. You only need to go as deep as the base of the sprinkler, no deeper. Always be careful not to hit the pipe or swing joint underneath. Next, push the sprinkler gently into that notch, fill in the soil on the opposite side, and pack it down. Replace the turf or mulch, and then turn on the sprinkler to make sure the spray is even. For sprinklers on slopes, this part's really important. The sprinkler shouldn't be vertical. It should actually be perpendicular to the slope. When it's set vertically, the water shoots high into the air downhill and straight into the ground uphill. Setting it perpendicular balances both directions, so you get full coverage uphill and downhill. On steep slopes, you'll also need to move the sprinklers a little closer together across the slope and shift the spacing slightly uphill to compensate for how the spray pattern gets distorted. When you see a sprinkler shooting a weird erratic stream, it's almost always a clogged nozzle. This looks very different from a clogged screen. Instead of a weak spray, you'll see a disrupted jet or misting in the wrong direction. Most clogs happen when the screen isn't in place, so step 1 is always to take that nozzle off. Don't just poke at it while it's still installed. The debris will drop back down into the body and clog it again once you turn the water on. After removing the nozzle, check for a screen. If it's missing or damaged, replace it. If you see the blockage, clear gently with a paper clip. If you can't see it, look inside the bottom of the nozzle and clear the internal ports. Be careful not to gouge the orifice. Even a small scratch can permanently distort the spray pattern. Once you're done, flush the sprinkler without the nozzle to push out any loose debris. Reinstall the nozzle, tighten it slightly beyond finger tight, and re-aim. When a single spray head looks weak while the rest of the zone is fine, that's usually a clogged screen. The nozzle might still spray, but the pressure's low and the stream won't break up properly. Most techs just replace these screens. They're cheap and they're usually stocked in the service truck, but you can clean and reuse them if needed. Just make sure you always use the correct screen for that nozzle model. Different nozzles have different mesh sizes, and using the wrong one can actually cause clogging or poor performance. For example, Rainbird uses blue screens for their van and he-van nozzles and clear ones for MPR or side strip. Toro Precision nozzles have a finer mesh and the screen is built in. You never want to operate those without it. To clean, remove the nozzle, rinse or brush the screen, and flush the sprinkler body. Reinstall everything and make sure the spray looks normal again. Rotating nozzles are much less likely to clog than sprays because they're built with fine mesh screens that trap debris before it reaches the internal ports. Some even have retractable tops or self-cleaning mechanisms that make them nearly maintenance-free. If one of those nozzles does clog, try flushing it while the water is running. Most models allow you to do that. If the clog won't clear or the model isn't made to flush, you'll need to replace the nozzle. Before installing a new one, always clean the screen thoroughly or replace it and flush the sprinkler body itself. That prevents debris from being blown right back into your new nozzle. Rotating nozzles are much more delicate inside with gears and micro ports that can easily clog if the screen isn't in place, so that screen is essential. Without it, the nozzle will clog permanently. Each brand has its own design, so you should only use the correct screen for that model. To clean one, remove the nozzle, pop the screen off the bottom, and rinse it under clean water. If it's really dirty, use a small brush. Flush the sprinkler before putting it back together so you don't send debris back into the screen. Then reinstall the nozzle, snug it down slightly beyond finger tight, and re-aim it. Rotor nozzles don't clog very often because they have large openings and built-in basket screens that trap debris before it reaches the nozzle. But if you've had a pipe break or there's a heavy algae or sludge in the system, even a rotor can clog. Another simple tool that can help with holding up the nozzle are these insertion or hold-up collars for rotors. You can put them on while you do your inspection while the rotor is on. They are typically brand specific. If the nozzle is clogged, remove the nozzle completely, inspect it, and either clean or replace it. Don't forget to pull and clean the basket screen. That's often where the problem starts. Once you've reinstalled everything, turn the water back on and check that the pattern and rotation look normal. If not, it's almost always faster to replace the nozzle than to keep trying to clear it. Rotor screens are at the very bottom of the internal assembly and they're easy to clean and reuse. If you've got a rotor that's turning slowly or looks low pressure, this is the first place to check. Start by taking off the cap and pulling out the internal. You'll see a little basket screen at the bottom, usually black or white plastic. Use pliers or a small screwdriver to pull it out, rinse it clean, and brush off any stuck debris. Then push it back in, flush the sprinkler body, reassemble everything following the same steps we used earlier for aiming rotors. After that, turn the water on and confirm the spray pattern looks even and the rotation is smooth. Nozzles can fail for a lot of reasons, but lawnmowers are public enemy number one. I've seen rotors decapitated by mower blades and sprays that split right down the side. Extreme cold or heat can also cause plastic nozzles to crack or separate. Once a nozzle is cracked, missing, or uncleanable, it needs to be replaced. But before you screw in a new one, always flush the sprinkler body first. That clears out sand, grit, or debris that could clog your new nozzle the moment you turn the system back on. Remember to check the riser and cap for damage too. Sometimes the impact that broke the nozzle also stressed those parts. For spray and rotating nozzles, replacement is quick and straightforward. Just unscrew the damaged one, inspect the riser and cap for any cracks, and make sure a clean screen is in place. Even if there wasn't a screen before, always install one now. It's a small detail that makes a big difference in preventing future clogs. Thread on the new nozzle, tighten it just a touch beyond finger tight with pliers, and re-aim the pattern so you're watering the right area. Rotating nozzles work the same way. Just remember that the screen is attached to the nozzle itself, and if that's missing or damaged, replace it before installing. Rotor nozzles take a little more effort to replace, but once you've done a few, it becomes second nature. For most small or medium rotors, you'll have replacement nozzles on your truck. They'll come with the rotors. Large commercial models are the ones that require separate nozzle sets. The first removal method uses water pressure. Turn on the sprinkler, raise the breakup screw using a hex key until it's just above the nozzle, and let the water push it out. Then flag that rotor and shut the water off. The second method is manual. Pull up the riser with a batwing tool, raise the screw just enough to release the nozzle, and remove it with pliers or a screwdriver. The old nozzle will usually be damaged during removal, so throw it away. Match your replacement nozzle to the same number and brand, line up the screw with the channel, and tighten it back in place. Then turn the water on to check the radius and fine-tune your adjustment. When we talk about trajectory, we're talking about the angle that the water leaves the nozzle. Sometimes we need to change that angle, especially if we're trying to throw water under tree limbs, around shrubs, or under a canopy. Spray nozzles come in different trajectory angles. Standard nozzles, like the 12, 15, and 17-foot models, throw water at around 27 degrees. The 10-foot nozzles and some 8-foot models are low-angle nozzles at around 15 degrees. Then there are flat nozzles around 0 degrees, which are great for tight spots and low plantings. Rotating nozzles don't have trajectory options yet, but many gear drive rotors do offer low-angle nozzles. Sometimes they're in the same nozzle tree as the standard ones. Other times they're sold separately. Lowering a sprinkler's trajectory isn't just about dodging tree branches. It's also a way to shorten the throw without distorting the pattern. When you use the breakup screw or radius screw to reduce distance, you're literally disrupting the nozzle's design. You can end up with uneven coverage or strange water distribution. But when you switch to a low-angle nozzle, you keep the manufacturer's performance intact while naturally reducing how far the water travels. For example, if a rotor with a standard 3.0 gallons per minute nozzle is throwing too far, swap it for a 3.0 low-angle nozzle. You'll get the same flow, but a shorter, tighter pattern. Just remember you're putting the same volume of water into a smaller area, so the precipitation rate goes up. Just make sure to adjust your controller run times or schedule accordingly. Over time, sprinklers can get blocked by lots of things: turf that's grown over the head, shrubs that have filled in, or even new landscaping. In this section, we're focusing only on turf growth because shrubs or trees usually require moving the sprinkler, which is covered later under repairs. With warm season turf like St. Augustine or Bermuda, it's not unusual for the grass to creep over the cap and prevent the sprinkler from popping up properly. Years ago, it was common practice to cut a bare ring of soil around every sprinkler. That made sense before spring retracted sprinklers were invented, but today it just creates bare patches, weed rings, and even trip hazards. The same goes for sprinkler donuts. They don't stop turf from overgrowing, they just make trimming and future repairs harder. The modern best practice is simple: only trim turf when it actually interferes with pop-up operation, and then trim neatly right into the edge of the cap. To fix an overgrown sprinkler, start during your normal maintenance check. Turn on the zone to spot which sprinklers aren't popping up all the way. Then flag those and shut the sprinkler and shut the zone off. Trim just the turf, not the soil, around the edge of the cap. You only need enough clearance for the riser to move freely. There are a variety of tools that make this easy. Some are simple handheld cutters, others attached to a cordless drill, and some even connect to a string trimmer. My favorite are the ones that can be used while the sprinklers are running. That way you can trim and check operation in one step. Be sure to pick the right size cutter for the sprinkler type and don't cut too deep or leave wide rings. The goal is a clean, safe trim that keeps the sprinkler functioning without creating a hazard or an eyesore. In this section, we covered how regular cleaning and adjustment keeps irrigation systems efficient and performing like new. We talked about fine-tuning the arc, radius, or trajectory so that water goes exactly where it's supposed to, and not on sidewalks, fences, or driveways. We learned how to clean clogged screens and nozzles, replace damaged components, and re-aim or straighten sprinklers for even coverage. We also focused on being smart with maintenance. Use the right tools for the job, but don't overdo it. Trimming turf should only be done when it's truly needed. The big takeaway: small, consistent adjustments prevent big problems. They keep water where it belongs, protect the landscape investment, and show professionalism in every service call.